Good morning, periods 2 and 3 CP Calculus class. This is Miss G here. It's Friday, March 20th. I'm sorry I'm posting a little late, but here's the video for today. It's on differential equations. This is the last lesson we'll do on section 5.1 before we go to 5.2 next week. So if you've been doing okay with the integration, which I think you may be because I haven't seen any questions that people have emailed me, so we could start right now. I think this lesson should be fairly easy for you. I hope so. So what we're doing is, here we go, we're finding the function f that satisfies the differential equation with initial conditions. We've done this before, but we haven't started with the second derivative. So we're starting with the second derivative, and we're going to integrate back to get to the first derivative, and then we're going to integrate that and get to the original function. So now we have essentially two steps instead of just one step, or integrating twice instead of once. So I'm going to do the example on page 320, number 51. They give us the second derivative of f of x is equal to 2. So f double prime of x equals 2. They also give us that f prime of 2 equals 5, meaning that the point 2, 5 will be on the f prime graph, and we'll use it to help us find c sub 1. And they also give us that f of 2 is equal to 10, meaning that the point 2, 10 is on the f graph, and we'll use that point to help us solve for c sub 2. So here we go. We start with f double prime of x is equal to 2. Now we're going to integrate that to get back to f prime. So f prime of x is equal to the integral of 2 dx. And I hope you recall that the integral of a constant with respect to x is just 2x. And then we throw in a plus c. But because we're going to do this twice, we're going to call the first c that we put in here c sub 1. Right now, before we integrate anymore, and before we integrate again, we're going to use a point 25 to solve for c sub 1. Remember, 2 is our x, 5 is our y. In this case, our y is really f prime of x. So 5 goes in for f prime, 2 goes in for x, and we work it out and solve for c sub 1. We get 5 equals 4 plus, need a c sub 1 right here, c sub 1. And that will give us that c sub 1 is equal to 1. So what we do is we're going to take original f prime here that we just solved for equals 2x plus c sub 1, and we're going to plug 1 in for c sub 1. So now we have the first derivative equation, which is f prime of x equals 2x plus 1. But we need the original function. So now we have to integrate again to get back to the original function f of x. So let's see what that looks like. So f prime that we just found was 2x plus 1. Now we're going to go to integrate and get f of x, and that's going to be the integral of 2x plus 1 dx. So we integrate 2x, and if you recall, we add 1 to the exponent, which gives us 2, and divide the current coefficient by the new exponent, and that will give us 2 divided by 2, or 1, as our coefficient here. So we get 1x squared, or x squared, plus the integral of 1 with respect to x, which is just 1x, or simply x. So plus x, and now we throw in a plus c, but this time it's going to be c sub 2. So now we're going to use the point that's on the f graph, and that point was 2, 10 that they gave us at the beginning of the problem. 2 is our x, 10 is our f of x, so now we plug 10 in here for f of x, and then we plug 2 in for our x. So we get 2 squared plus 2 plus c sub 2. We solve that, we get 6, 10 equals 6 plus c sub 2, so c sub 2 is 4. Then we rewrite our f of x exactly the same, except we replace c sub 2 by the value we just found, which was 4. So our solution is f of x equals x squared plus x plus 4, and that's it. So you're just integrating twice, once to get f prime, and then the second time to get the original function. All right, so your assignment is page 320, numbers 52, 53, and 54. They're just like this. And I left the final answers. Be sure to do all your work, show your work. When I probably will collect this work at some point and give you credit for it. So show your work and don't lose your assignments that you do out. For points, you'll get points for this. All right, so here are the 3 answers. You can see them, and you can check your answers after you do the work. And let's see, if you have any questions, email me, and I will be happy to do those problems if you request them on my next video, which will be Monday. All right, I hope you all have a great weekend, and we made it through the first week. Hooray! Have a good one. Bye.